Imagine standing inside a factory where a single truckload of liquid chemicals can suddenly expand into enough insulation foam to fill an entire apartment building. Most people see insulation foam hidden behind walls and never think about it again. But here's what nobody tells you. This lightweight material traps millions of tiny gas bubbles so effectively that it can slash energy loss by more than half. Today, you're about to follow an incredible journey from raw chemicals to the silent shield protecting homes, warehouses, and skyscrapers around the world. Think about this. A block of insulation foam looks almost weightless in your hands, yet it begins its life as a carefully engineered chemical system developed through decades of research. Inside these factories, temperatures, pressures, and chemical reactions must stay perfectly controlled. One tiny mistake can ruin thousands of dollars of product in minutes. And what happens next surprised even experienced engineers. As we move deeper into the process, you'll discover where the chemicals come from, how they transform into billions of microscopic cells, and why some foam can survive inside buildings for decades. You'll hear the roar of mixers, see chemicals erupt into expanding clouds, and witness quality tests that push foam to its limits. By the end of this journey, you'll never look at a wall the same way again. Most rigid insulation foam begins with two critical ingredients, polyols and isocyanates. Many polyols originate from petrochemical facilities along the Gulf Coast of the United States, parts of Germany, Saudi Arabia, and China. The raw hydrocarbons often start their journey deep underground in oil and natural gas fields before entering massive, refining complexes. A single production facility may consume hundreds of tons of these ingredients every day. Some modern manufacturers now blend bio-based polyols made from soybean oil, castor oil, or recycled organic feedstocks. Farmers may harvest these crops thousands of kilometers from the final foam factory. Tankers, rail cars, and specialized chemical trucks move the liquids through a supply chain stretching across continents. Most people never think about this hidden transportation network working around the clock. The purity requirements are astonishing. Many foam producers demand chemical purity above 99% because tiny contaminants can disrupt the cellular structure inside the finished product. Engineers continuously sample incoming shipments before unloading begins. Even a small deviation can affect insulation performance for years after installation. Another ingredient plays a surprisingly important role, blowing agents. These compounds help create the microscopic bubbles trapped inside the foam. Earlier generations used chemicals that damage the ozone layer, but modern facilities increasingly rely on lower-impact alternatives which dramatically reduce environmental footprints. And this is where the story takes an unexpected turn. Before manufacturing begins, enormous storage tanks hold the ingredients under carefully controlled conditions. Pumps circulate liquids continuously to maintain consistency. Sensors monitor temperature, viscosity, and contamination 24 hours a day. Hidden behind these steel walls, the factory prepares for a chemical transformation that looks almost alive. Exceeding 100 bar, now, the real magic begins. Operators pump polyol and isocyanate streams into precision mixing systems. Typical processing temperatures range from 20 to 30 degrees Celsius, or 68 to 86 degrees Fahrenheit. High-pressure pumps can deliver chemicals at pressures by 1,450 psi, creating the perfect conditions for rapid blending. Inside the mixing head, rotating components can spin at thousands of RPM while the chemicals collide at extraordinary speed. The sound resembles a powerful jet of compressed air. The mixture remains liquid for only seconds before the chemical reaction accelerates. What happens next looks more like science fiction than manufacturing. As the chemicals react, they generate heat naturally. Internal temperatures can climb above 120 degrees Celsius or 248 degrees Fahrenheit. Carbon dioxide or specialized blowing agents create billions of expanding cells throughout the mixture. You can almost hear a soft crackling sound as the foam rises and grows. In continuous production lines, moving conveyors carry the expanding foam at speeds of roughly 1 to 5 meters per minute. The material swells to many times its original volume. Workers watch carefully as the surface changes from glossy liquid to a solid cellular structure. The smell of warm chemicals and fresh foam fills the air. For large, rigid foam blocks, curing may continue for several hours. During this period, trapped gas is stabilized and the internal structure strengthens. Massive foam buns sit in designated curing zones while temperatures gradually fall. Most people never see these enormous blocks before cutting transforms them into familiar products. Next comes precision cutting. Computer-controlled saw systems slice blocks into panels with tolerances measured in millimeters. Long blades move smoothly through the material, while extraction systems remove dust. What happens next surprised even experienced engineers, because this step determines whether the foam performs flawlessly for decades. Some specialty foams receive laminated facings made from aluminum foil, fiberglass, or polymer films. Automated rollers apply these layers at carefully controlled speeds. The finished panels emerge looking clean, simple, and ordinary. Yet inside each one lies an engineered structure containing millions upon millions of microscopic cells. Modern insulation foam factories resemble advanced technology centers as much as manufacturing plants. Laser scanners measure dimensions continuously. AI-powered vision systems inspect surfaces for defects invisible to the human eye. Thousands of sensor readings flow into central control rooms every second. Robotic handling systems move heavy panels with remarkable precision. Automated guided vehicles transport materials between production zones without human drivers. Cameras track every movement, while software predicts maintenance needs before equipment fails. Most people never imagined this level of intelligence behind insulation foam. Quality control begins almost immediately after production. Technicians measure density, thermal conductivity, compressive strength, and dimensional stability. Some facilities reject 1 to 3% of output before it ever reaches customers. Even tiny defects can affect long-term performance. Engineers cut sample panels and inspect their cellular structure under magnification. They search for irregular bubbles, voids, and weak zones. Tolerance requirements may stay within fractions of a millimeter. Under bright inspection lights, every imperfection becomes impossible to hide. Some tests push the material to extremes. Compression machines crush samples with immense force. Environmental chambers expose foam to cycles of heat, cold, and humidity that simulate years of real-world service. What happens next reveals whether the product deserves international certification. Yet, even in highly automated factories, human expertise still matters. Veteran operators can sometimes detect subtle changes in sound, texture, or foam rise behavior before sensors register a problem. Their experience protects production lines worth millions of dollars. And this human-machine partnership remains one of the industry's greatest secrets. Today, insulation foam supports one of the largest energy efficiency industries on Earth. Global production reaches many millions of metric tons every year, serving construction, refrigeration, transportation, and industrial markets. The worldwide insulation materials market generates tens of billions of dollars annually. Imagine stacking the yearly output into a mountain visible from space. China, the United States, Germany, Japan, and India rank among the most significant producers and consumers. Together, they account for a large share of global demand. Hundreds of thousands of workers contribute directly or indirectly to the supply chain. Every shipment connects chemists, engineers, drivers, installers, and building designers. Did you know that modern insulation can save far more energy during its service life than manufacturers consume while producing it? Did you know that tiny gas-filled cells inside foam perform the same basic job as a winter jacket trapping warm air? And did you know that a few centimeters of advanced foam can dramatically reduce heating and cooling costs for decades? 50 years ago, insulation foam manufacturing relied on less efficient chemistry, simpler controls, and fewer environmental safeguards. Today's factories use advanced automation, cleaner blowing agents, and precise process monitoring. The transformation has been extraordinary, but the next decade may bring an even bigger revolution. Researchers continue developing bio-based feedstocks, recyclable foam systems, and lower carbon manufacturing methods. Smart factories will likely rely on even more artificial intelligence and predictive control systems. What happens next could reshape the way buildings consume energy across the entire planet. And this story is still being written. From underground hydrocarbons and agricultural feedstocks to precision chemistry and advanced automation, you've witnessed a complete journey of insulation foam. What began as liquid ingredients traveled through heat, pressure, expansion, cutting, testing, and certification. Most people never think about the invisible barrier hidden inside walls and roofs. Yet this material quietly protects comfort, reduces energy waste, and shapes the modern world around us. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.